Hi, in today's video I would like to share with you a very nice problem of Japanese Mathematical Olympiad year 2005, question number 3. Okay, here is the setup. We have all positive real numbers a, b, c such that the sum of these numbers a plus b plus c equal to 1. Okay, our goal, we are going to prove this statement as a capital A equal to little a is multiplied by the cube, the root of this number 1 plus b minus c, plus b is multiplied by the cube root of this number, which is 1 plus c minus a, plus c is multiplied by cube root of 1 plus a minus b. The entire thing is inferior or equal to 1. Okay, in fact this problem is full with tricks. That's normal for the mathematical Olympiad competition. However, you need to work out and find those tricks as you work in. Sometimes you work on this type of this problem, then you get stuck at the same point, then you try to change another method which is mess and wasting of the time. Okay, so always when you find this type of these problems, the most of the times you are going to apply the EMGM theorem, arithmetic mean geometry mean value theorem, which is written on this form as x1 plus x2 and all the way down to the xn is divided by n terms, depends how many terms that you have here, that's superior or equal to the nth root of this product of these numbers x1 through to xn. Okay, the second observation you are going to observe, especially in this problem, this inequality is facing in the opposite way as this theorem is. Okay, so anyway, in order to make the combination and apply this theorem here, because it's more powerful and useful theorem, we are going to assume this inequality is strictly superior than 1. At the end of term we will find the contradiction. Now let's get to the solution. So we are going to assume this one is strictly superior than 1. Okay, so this term I can write on this form as well. A is multiplied by 1 plus b minus c to the 1 over 3 plus strictly superior than 1. Okay, we are going to consider this inequality strictly superior than 1. So at the end of term we will find impossible to have this one true. Okay, now I'm going to apply EMGM directly here. I will get the capital A is superior or equal to, we have 3 terms, 1 2 3 terms here, is multiplied by this product a to the 1 plus b minus c to the 1 over 3 is multiplied by the b and multiplied by 1 plus c minus a to the 1 over 3 is multiplied by c is multiplied by 1 plus a minus b to the 1 over 3. But don't forget, this one will be raised to the 1 over 3 again, because we are applying this term exactly as is it, because we have cubed the root. Okay, here I'm going to rearrange these numbers by taking the product of ABC separately from this exponent. So we'll get capital A is superior or equal to 3 times ABC to the 1 over 3 is multiplied by this product 1 plus b minus c is multiplied by 1 plus c minus a is multiplied by 1 plus a minus b. Okay, so this product is raised to the 1 over 9. Okay, now the second thing that I'm going to do now, as we have a plus b plus equal to 1, I'm going to replace number 1 with this sum. Okay, so I will get a capital A is superior or equal to 3 a b c to the 1 over 3. Number 1 will be replaced with a plus b plus c plus b minus c is multiplied by a plus b plus c plus c minus a is multiplied again by this product a plus b plus c plus a minus b. The whole thing is raised to the 1 over 9. So I will have some cancellation here. The capital A is superior or equal to 3 is multiplied by EBC to the 1 over 3. So number c will be cancelled out because one is positive, the other one is negative. In the second term, I will have a, it will be cancelled out. The third term or last term, b will be cancelled out as well. So I'm going to rewrite this one again here. So I will get a plus 2 times b is multiplied by b plus 2 times c is multiplied by c plus 2 times a. Okay, the entire thing will be raised to the 1 over 9. If you take a look again at this product, you will see a nice symmetry for individual term. Okay, now at this point I already applied this AMGM, but it didn't take me to the solution. So what's wrong here? So now is required to apply this one again one more time. Okay, let's stick this one at the top and continue with our problem. In the last board I was working on this inequality and came up with this product. The nice thing here, since every term of this product is written in terms of 2 terms, so now I can apply this theorem again. Okay, let's apply this theorem on every individual term in this product. Let's take the first term. So we'll have a plus 2b by applying AMGM. Since I have 2 terms here, is multiplied by this product 2 times ab to the 1 over 2. Okay, for the second term I get b plus 2 times c is superior equal to 2 times this product, which is 2 times bc to the 1 over 2. For the last term I get c plus 2 times a is superior equal to 2 times 2 is multiplied by ac to the 1 over 2. Okay, so I'm going to raise both sides of this first inequality to the 1 over 9 as an exponent. So this one equivalent a plus 2b to the 1 over 9 is superior equal to 2 is multiplied by 2 times ab to the 1 over 2. The whole thing, it will be raised to the 1 over 9. So I'm going to simplify this one more. We'll get 2 to the 1 over 9 and is multiplied by 2 to the 1 over 2 to the 1 over 9. Okay, I'm going to separate number 2 from AB and take it outside of this product. Okay, I will get 2 to the 1 over 9 is multiplied by 2 to the 1 over 2 is raised to the 1 over 9. For the AB, since I have the original exponent is 1 over 2 is raised to the 1 over 9, the whole thing is given as 1 over 18. Okay, so the same thing here, I get 1 over 2 to the 1 over 9, which is 1 over 18. Okay, I will get 1 over 18 here. Then I have 2 to the 1 over 9 is multiplied by 2 to the 1 over 18 by applying the exponent rule. I will get here 1 over 9 plus 1 over 18. By multiplying numerator and denominator by 2, I will get 2 plus 1, which is 3. 3 over 18 is given as 1 over 6. Okay, so I'm going to replace this exponent with 1 over 6. Is given as 2 to the 1 over 6 is multiplied by EB to the 1 over 18. Okay, this argument follows similarly for the second term. Okay, I will have the same thing as before. Okay, so instead to put 8 plus 2b, I will put b plus 2c. Okay, for the b plus 2 times c to the 1 over 9 is superior or equal to 2 is multiplied by 2 bc to the 1 over 2. The whole thing is raised to 1 over 9. So this one will be the same thing, is superior or equal to 2 to the 1 over 6 is multiplied by bc to the 1 over 18. I will have the same thing for the last term. Okay, because I have a nice symmetry here, that's why everything will be repeated on the same form. Okay, so for the last term I will get c plus 2 times a to the 1 over 9 is superior or equal to 2 to the 1 over 6 is multiplied by AC to the 1 over 18. So now what I'm going to do now, I'm going to make a nice product here by multiplying the first term by the second term by the third term. Okay, so I will get as a capital A is superior equal 3 times ABC to the 1 over 3 is multiplied by these three numbers which I found before. 2 to the 1 over 6 is multiplied by AB to the 1 over 18 is multiplied by the second term, which is 2 to the 1 over 6 is multiplied by BC to the 1 over 18 and is multiplied by 2 to the 1 over 6 is multiplied by AC to the 1 over 18. Okay, now I'm going to rearrange these numbers. I will get a capital A is superior equal to 3 times ABC 1 over 3. I'm going to rearrange all these numbers by putting number 2 in the front. I will get 2 is multiplied by 1 over 6 is multiplied by 2 to the 1 over 6 is multiplied by 2 to the 1 over 6. Here I will get A squared because I'm going to put all these numbers inside each other. So I'm going to rearrange all these numbers ABC together. I will get A squared is multiplied by B squared is multiplied by C squared. But A squared is multiplied by B squared is multiplied by C squared. The whole thing is raised to the 1 over 18. And then this one is giving us 3 times ABC, 3 times ABC to the 1 over 3. So by putting this exponent together, I will get 2 to the 1 over 6 plus 1 over 6 plus 1 over 6. Okay, we'll get 2 to the 1 over 6 plus 1 over 6 plus 1 over 6 is multiplied this A squared ABC. I put this one as ABC square is raised to the 1 over 18, which is 1 over 9. Okay, because there is a square here. By putting this ABC inside of this one, I will get 3 times this 1 over 6 plus 1 over 6 plus 1 over is given as 3 over 6, which is 1 over 2. 1 over 2 here. For ABC, I will get ABC is given as I'm going to multiply numerator and denominator by 3. I will get 3 plus 1, which is 4. I get 4 over 9. Okay, I will get 3 is multiplied by 2 to the 1 over 2 is multiplied by ABC to the 4 over 9. Okay, I'm going to clean up this board and bring this one at the top and finish off this problem. In the last board, we were working on this inequality and came up with this result, and continue investigating this inequality in order to have a contradiction. Now we are ready to create a contradiction. But here is the thing here. This number 3 is multiplied by 2 to the 1 over 2 is strictly superior than 1. That's not the one we want. We want this whole number must be strictly inferior to 1 to build the contradiction. Okay? So, but this problem is Mika's problem, because we don't know the value of this number here. But we know the sum of these numbers equal to 1. When you apply the product of those numbers, the numbers become more smaller. As you increase in the exponent, the product become more smaller and become more super smaller. Okay, we want to transfer this product into smaller number to help us to bring this big number, which is strictly superior than 1, to become smaller than 1. Okay, so the only information that we have, the sum of these numbers equal to 1. Let's consider, if you ignore, for instance, if you ignore these numbers, you say this product is strictly superior than 1. I know it's strictly superior than 1, but I don't know the value of these numbers, how much small is. Okay, so now I'm going to consider two cases. Let's consider the first case. Case number 1. If A equal to B equal to C equal to 1 over 3. Because third plus third plus third is giving us 1. Okay? So let's take this case. Let's plug this information into this inequality. This inequality become a capital A is superior or equal to 3 is multiplied by 2 to the 1 over 2 is multiplied. This product ABC become A cubed because we are taking equality here. This one is raised to the 4 over 9. This one become 3 is multiplied by 2 to the 1 over 2. I'm going to simplify this one. I will get A to the 3 multiplied by 4. I'm going to have some simplification here. I will get 3 is multiplied by 2 to the 1 over 2. By cancelling out number 3 from exponent, I will get A to the 4 over 3. Okay? By replacing A with third, I will get 3 is multiplied by 2 to the 1 over 2. 1 over 3 to the 4 over 3. I'm going to make that kind of cancellation here. I will get 3. I'm going to split this exponent into two parts. I will get 3 is multiplied by 2 to the 1 over 2. 1 over, I'm going to work this 1 over 3. This exponent become 3 is multiplied by 3 to the 1 over 3. Okay? So now I will have a nice cancellation here. Number 3 will be cancelled out. So this one, I will get 2 to 1 over 2 is a square root of 2. Is divided by cube 3. So what do you know about this number? This number is strictly inferior than 1. Okay? So now I have a capital A, which is this one, is superior or equal to this number, square root of t, square root of 2 is divided by cube 3, but this number is strictly inferior than 1. But we assumed before this number must be superior or equal to 1. But we found this number is strictly inferior than 1, which is impossible. Impossible, okay? So let's consider the second case. Case number 2. For the case number 2, if A is strictly superior than B is strictly superior than C. Now we see what's gonna happen. Now this one equivalent, A strictly superior than B and B strictly superior than C. It's equivalent. So now in this inequality, I'm going to multiply both sides by BC. I will get ABC is strictly superior than B square C. Okay? Multiplying BC on both sides is giving us this one. In the same time, B square C, if I'm going to raise number 2 as a power in the second inequality, I will get B square is strictly superior than C square. But by multiplying both sides by C, I will get C cubed here. So B square C is strictly superior than C cubed. Okay? So now ABC is strictly superior than C cubed. What I'm going to do now, I'm going to raise 4 over 9 as an exponent on both sides. I will have some simplification here in the exponent. I will get C to the 4 over 3. I'm going to multiply both sides by this number. I have a capital A superior or equal to 3 is multiplied by 2 to the 1 over 2 is multiplied by ABC to the 4 over 9. This number, as I have here, is strictly superior than 3 is multiplied by 2 to the 1 over 2 is multiplied by C to the 4 over 3. Here is clear. At this point it's so clear. But here is a second problem here. You don't know the C now here. But if you take a look at the sum, we have the sum of these numbers equal to 1. So look at this equality. When you have A equal to B equal to C equal to third. But now, in the second condition now, when we have A is strictly superior than B, and then B is strictly superior than C, now the C become a smaller number comparing to other numbers, A and B. So what does this mean? That means C equal to 1 over 3 is a maximum number that C can take. In this case, since we have C is very small number, that means C is strictly inferior than 1 over 3. What I'm going to do now, I'm going to raise both sides. I'm going to raise both sides to the 4 over 3 as an exponent. So I will have some simplification here. So this one, I will have 1 over 3 to the 4 over 3. This exponent is given as 3 is multiplied by 3 to the 1 over 3. So this number will be strictly inferior than 3 is multiplied by 2 to the 1 over 2 is multiplied by this number, which is 1 over 3 is multiplied by 3 to the 1 over 3. Now I will have a nice cancellation here. 3 will be cancelled out with 3. This number become 2 to the 1 over 2, which is square root of 2, is divided by cubed of 3. If you calculate this number, you will find 0.98, which is strictly inferior than 1. Since A is strictly superior than this number, which is 3 is multiplied by 2 to the 1 over 2, is multiplied by C to the 4 over 3. In the same time, this number is strictly inferior than square root of 2 is divided by cubed of 3, which is strictly inferior than 1, which is a big contradiction here. Okay, since both cases are indicate a contradiction, that means our assumption was wrong. But we are not done yet, because we were working on this condition when you have A strictly superior than B, strictly superior than C. But there are another cases when you have C is strictly superior than B is strictly superior than A. And then third case, when you have B is strictly superior than A and strictly superior than C, or whatever. Okay? But since we have a symmetry here, that means A, B, and C are playing the same role. That means this argument follows similarly to other numbers, B or C. All the cases are indicating it is impossible to have this sum is strictly superior than 1. At the end, this sum must be inferior or equal to 1. Okay? So I have done with this problem. If you have any question or suggestion, just put it in the comment section below. Just don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.